This is the second video of section 6.3, exponential functions. In this video, we're going to talk about more transformations of exponential functions. In the first video in section 6.3, we talked about what A controls when we talk about exponential functions and graphing exponential functions. But you see here we have two more variables, H and K. And I don't have them written here because I want to write them in as I talk about them. So the first one is H, and I'm actually going to make that minus H. So I need to fix that. It's not going to be plus H, it's going to be minus H. And what minus H does is it controls the horizontal translation. We've seen that before. When we subtract something directly from X, that's a horizontal translation. And remember, when we're talking horizontal translations, anything horizontal, something is always different about it. In this case, just like with other transformations or translations specifically, we go the other direction. So if we think about minus 2, that actually means to the right. If we think plus 3, that actually means to the left. And then the last one here is K, and that goes on the very end of the function, not part of the exponent. It's after the exponent. Just like with other transformations, it controls the vertical translation. We're adding something on the end of the function, not directly to X. So the minus H, the plus K, those are our two additional transformations that we need to consider when we're graphing exponential functions. Okay, so steps for graphing. Identify the parent function, kind of outlining what we talked about in the previous video. Identify the parent function, we're going to graph the parent function, then we're going to identify the transformation or transformations, could be more than one, and then we're going to apply the transformation or transformations, and we need to apply them in this order. Horizontal translation, vertical stretch and shrink, and also a reflection if there is one, and then the vertical translation goes last. Okay, so let's do a couple of examples here. Graph the function, describe the domain and range. So number 1, y equals 3 times 2 to the x minus 1 power minus 3. Let's start by identifying the parent function. The parent function is y equals, and remember, just from the previous video, it's the base, the exponent, and that's it. So it's going to be y equals 2 to the x power. Okay, so if we wanted to make an xy table for this, xy, we're going to use those same five numbers that we usually do, -2, -1, 0, 1, and 2. And we're going to find the y values, again, just by plugging these 5 x values in for this x. So 2 to the 0 power, anything to the 0 power is 1. Anything to the first power is itself, so 2 to the first is 2. 2 to the second power, 2 times 2 is 4. And again, if we're multiplying by 2 this way, we're going to divide by 2 going this way. So 1 divided by 2 is a half, and a half of a half is 1/4. So we have our parent function. So let's bring in some graph paper here and let's draw in our graph. So, whoops, I need to switch that to black. So let's try that again. Black line for the x and y axis, and we'll do this, we'll just make it a little narrow. There we go. Okay, so we have our graph for the x and y axis. Let's put our points on the graph. 0, 1 is there. 1, 2 is right here. 2, 4 is here. -1, a half is there. -1, a fourth might be somewhere in there. And we can draw our curve through those points. Again, get as close as you can. Again, once again, not crossing this x-axis. Okay, so let's check our steps. Identify the parent function, done. Graph it, done. Now we need to identify the transformation. So I'll do that in purple here. So transformations. We have multiple here. Transformations. So the first one, let's write them in the same order that we have to apply them. So horizontal translation, that's the one right here up with x. So that's going to be 1 unit, and again, with horizontal, it's backwards. Normally we think -1, we go left on the number line, but this is actually 1 to the right. Okay, 1 unit right, that's the first one. Second one, we need to think about vertical stretch and shrink and or a reflection in the x-axis. This number right here is not negative, so it's not a reflection. So it's going to be just a stretch or shrink by a factor of 3. So if it's a factor of 3, that's bigger than 1, that means we have a vertical stretch. So vertical stretch, see if I can kind of fit that on there, by a factor of 3. And then the last thing we need to identify, the vertical translation, that's this number out here on the end, the -3, and with vertical, directions are always normal. So our final transformation here is, whoops, not 1 unit down, but 3 units down. 3 units down. Okay, so we have our transformations. Let's apply them, and I'm going to do these transformations in green. Okay, so let's bring this back down here. See if I can't fit it all. Get close. All right, so we're going to start with this point right here on the y-axis. We're going to go 1 unit to the right. Okay, so now we're here. Vertical stretch by a factor of 3. So right now we are 1 unit above the x-axis. So when we stretch that, it becomes 3 units. 1 times 3 is 3. So now we're here. And now our last thing is to go 3 units down. So 1, 2, 3 actually puts us back on the x-axis. So this point right here ended up right here after our transformations. Let's do another point. So let's start with this point right here, this 1, 2. So we're going to go 1 unit to the right, so that's now over here. Vertical stretch by a factor of 3. Right now it is 2 units above, and we take 2 times 3 and we get 6. So we're going to go 2, so that makes us up to 6. And then the last thing is 3 units down. 1, 2, 3. Our new point is going to be, whoops, I'm going to go back to the pen, right there. Do it again with this point. So we are 1 unit right, and then we're going to go vertical stretch. So 1, 2, 3, 4, 4 units above. 4 times 3 is 12, so 5, 6, 7, 8, 9, 10, 11, 12. I think that would be 12. Let's try that. Check that again. 5, 6, 7, 8, 9, 10, 11, 12. There's 1 off. Vertical stretch by a factor of 3 puts us here, and then 3 units down. 1, 2, 3. So we are right in there for our last point. That's not very good. Let's put it back on the intersection. There, that looks a little better. So there's the 3 to the right. Let's do the other 2 real quick. So this one here, this half, we're going to go 1 to the right. We're going to vertical stretch by a factor of 3, so that's a half above right now. A half times 3, half of 3 is 1.5, so we're going to go up to 1.5, and then we're going to go 3 units down. 1, 2, 3. So we are now pretty much right here where that black line ends, and I need to kind of extend this line. Let's do something like that. That'll work. And we have one more point to do. This one right here, this 1/4, we're going to go 1 unit to the right, vertical stretch by a factor of 3. So 1/4 times 3. If I have 3/4, that means I have, well, 75 cents or 3/4. So that's right about in here somewhere. Okay, and then we're going to go 3 units down. 1, 2, 3. So we're going to be roughly right in this area. Now, normally we talk about the x-axis being the line we're not going to cross. When we shift everything down, this line that we're not going to cross also shifts down 3 units. So now it's going to be this line right here. So that's the line that we are not going to cross. It's going to look something like this. That is what our picture looks like. And let me draw this in purple. That line that we're not going to cross is right here. Normally it's this line, the x-axis, but since we shifted the graph down, this line that we don't cross is also going to shift down. Let's try another one here. Y is equal to -2 times the quantity 3 to the x plus 2 power. Don't mind the bell in the background. And then -1. So first thing we need to do is we need to identify our parent function. And again, the -2 out front, the +2 up there, the -1, they don't mean anything in terms of the parent function. The parent function here is going to be y equals 3 to the x power. Okay, so we'll make our table here. X, Y, 5 spaces, 2, 3, 4, and 5. Extend those just a little bit. Those x values are going to be the same. -2, -1. Ooh, let's try that again. -1, 0, 1, and 2. And then go ahead and plug in these x values right here for x. 3 to the 0 power is 1. 3 to the first is 3. 3 squared is 9. 3 to the negative first power really just means reciprocal, so the reciprocal of 3 is 1/3, and negative second power means the reciprocal squared, so 1/3 times 1/3 is 1/9. And there is our table. We now need to graph, so let's bring in some graph paper here. I need to draw in my x and y axis here, give myself plenty of room. Let's just see what this will do. We'll bring this up just a little bit farther. Okay, so we have our x and y axis. Let's graph this. 0, 1 is right there. 1, 3, 2, 9, 6, 7, 8, 9 is right there. Okay, so we have that. And then -1, 1/3 might be somewhere in there. And 1/9 might be right in there. Probably a little closer to the x-axis, but again, with the capabilities of this stylus, this pen I'm using on the iPad, not always conducive to getting really, really close together. So we'll draw our curve. Looks like this, a little steeper than 2 to the x, but we have our parent function. So let's identify our transformations. So start with the horizontal transformation. That means we're going to go 2 units left. Okay, the +2 directly to x means we're going to go 2 units to the left. 2 units. That's really bad too. The next one would be the number out front. I'll do that in a different color. Let's do that in, we'll do that one in orange. So that's this one. We actually have 2 transformations there. We have the stretch, because the number is bigger than 1, stretch by a factor of 2, and a reflection. And then the last one here we'll do in brown, I guess. We'll do that the -1. What that one does is a translation. We're going to go 1 unit down. So we'll see what we can get on this picture. We'll just kind of make it work. So transformations, I'm going to make the dots in green on the graph here. Let's see if we can follow this. So let's start right here. We're going to go 2 units to the left. So 1, 2. Stretch by a factor of 2. So right now we are 1 unit above. So when we double that, we're going to be 2 units above. And we need to reflect it. So I was right here. I'm going to reflect it. I'm 2 above. So when I reflect it, it's going to be 2 below. And then I have to go 1 unit down. So I'm going to go 1 more down to right in this vicinity. So right there. That is this point after all the transformations ends up right there. Let's do the next point. Let's do this one right here. We're going to go, let me check again, 2 units to the left. So we're going to go 1, 2 units to the left. We're going to stretch it by a factor of 2. So right now it is 3 above. When we double that, it becomes 6 above. And then we need to reflect it from 6 above to 6 below. So 3, 4, 5, 6. We might be looking right in here for this point. This point goes right there. Okay, the next point, this one right here, I think it's going to be really, really difficult to get this one on the graph just because, you know, it's already 9 units above. We're going to double that to 18 and then reflect it. I don't think that one's going to be able to fit. So we'll kind of ignore that one for now. Well, maybe we'll see if we can come back and do it once again. All right, so this point right here, we're going to go 2 units to the left, 1, 2. We're going to stretch it by a factor of 2. So right now it is a third of a unit above. 1/3 times 2 is the same thing as 1/3 plus 1/3, which is 2/3. So that's barely going to move. And then we need to flip it over. So if it's 2/3 above, it's going to be 2/3 below. So it's going to be right in this area, top of the circle there. And then 1 unit down. So we're going to go right into about here. Okay, that might be somewhere in there. And then the last point over here, it's 1/9. So we're going to go 2 units left over to there. We're going to double it. So 1/9 times 2 is 2/9. So it might move to like there, barely moves. Then reflect it. So if it's 2/9 above, it'll be 2/9 below. So maybe about in there. And then we need to go 1 more unit down. It's going to be right in that area, right in here. So that's kind of what our shape looks like. I think we can see our shape. We don't necessarily need to move this point right here just because, again, we can go 2 units left, but then it's 9 above, which becomes 18 above, which is way up there. It's something we can't exactly see. And then when it comes way down there, again, it's going to be really stretched out. I don't think it's really necessary. So let's draw our curve. Remember, we went here. This was our original line that we're not going to cross. The transformation with 1 unit down changes this. So instead of being the x-axis, this purple line here, it's now going to be 1 unit down. It's going to be this line right here. Okay, so that curve of ours should not cross or touch. Let me move this down so we can finish the graph. Is not going to touch or cross this line now, this y equals -1, because we slid everything down 1 unit. I just realized once again, just like in the last video, I haven't done domain and range yet. So let's go back to this graph. We need to talk about the domain and range. So we'll do domain and range. We'll do that one in orange for this one. So the domain, just with any other exponential function, the domain is always all real numbers. Okay? Or the quick way to write that, the R with the vertical line going right through it. The range for this one, so we're going up forever this direction, but as we come back this direction, we really flatten out. We're going to get to a point where we're not going to cross this line, and we talked about that earlier. Okay, we're not going to cross this line. This line, instead of being 0, like in the original functions, it's now 1, 2, 3 down. So the range here is going to be y. That number we're not going to get to is -3, and since we're above it, our range is going to be y is greater than -3. Let's take a look at this one. The domain here, just like with every other exponential equation, all real numbers. The range this time, So this time as we go out to the right, we're getting really, really small. So we're going to have a y is less than something. We're going to max out over here, and we go down forever this direction. What is this number that we get really close to? Well, here it was 0. We went 1 unit down, so now that line is going to be -1. So that number is going to be -1. Okay, y is less than -1, and that's the domain and range for both of those examples. The last thing we need to talk about in section 6.3 is writing exponential equations. So we've talked a lot about graphing exponential equations and evaluating with exponential equations. Now we need to work on writing exponential equations or functions, okay? So we're going to be working with the basic exponential function, a times b to the x, and what we need to find are these two numbers. We need to find a and we need to find b. Our answer is always going to have a y and an x in it. We need to figure out what these two numbers are, okay? So a, which your a is equal to, is the y value when x is equal to 0. So you'll be given enough information that you can figure out the y value when x is equal to 0. Usually you're going to be given a table or a list of ordered pairs. All you need to do is find the x value of 0, and the y value with that point is going to be your a value. Now your b value is what y is multiplied, or what you multiply by, what y is multiplied by to get the next number, to get the next y. Okay, so if we multiply by 2 as we go to the right, then our b value is 2. If we're dividing by 2, then our b value is 1/2. That might be something to note, and I've got an example where that does happen, so maybe we can write that down in just a second. So this, let me write that in pen. That one is the y, what y is multiplied by to get the next y value. Okay, so let's do a couple of examples here. Write an exponential function to model the information. So we need to know two things. We need to know a, we need to know b. I'll do those in each color. So our a value, remember, it's the y value when x is 0. So we have an x value of 0. The y value is right here. This is our y value right here, negative, or our a value right there, -2. Okay, the next thing we need to figure out, and I'm actually going to erase that and write that just a touch lower. So a, whoops, pen here, a equals -2. It's this part right there. Now b, to find what we're multiplying by, whoops, need to move this up. B is what y is multiplied by to get to the next y. So how do I go from 2 to -2 to -6? Well, I'm pretty sure that's times 3. And from -6 to -18, that's also times 3. And from -18 to -54 is also times 3. So our b value here is what we're multiplying by. So that's going to be 3. So now once we have those two pieces of information, when we want to write our equation, a times b to the x, all we need to fill in are a and b. And our answer here is going to be y equals our a value, which is -2, times our b value, which is 3. And you can use times or you can use parentheses, doesn't matter, to the x power. And that right there is our answer for question number 1. Question number 2, or example number 2. We have our table. We need to figure out our a and our b. So our a is pretty straightforward. It's the x value, or it's the y value when x is 0. So a is equal to 16. Then the b value. Now, to go from 32 to 16, that is dividing by 2. 16 to 8, also dividing by 2. 8 to 4, dividing by 2. And then from 4 to 2, you guessed it, that's dividing by 2. Now, we want to know what y is multiplied by. Okay, it has to be what we're multiplying by to get the next y. And right now we're showing that we're dividing by 2. Well, how do we remedy that? Well, dividing by 2 is exactly the same thing as multiplying by 1/2. Just like dividing by 4 would be the same thing as multiplying by 1/4. Okay, if we're dividing by a number, it's the same thing as multiplying by its reciprocal. So our b value here in this case is going to be 1/2. So we can write our equation, y equals a times b to the x, and we can fill in what we know, what we need to know. We need to know a and b. We have those right here. Let's write our final answer. Y is equal to our a value of 16 times our b value of 1/2 to the x power. And that's all there is to it for this type of example.